In this video, we are going to learn how to build and evaluate truth tables. Before we get into an actual table, there are values that you have to know for each symbol. So anytime we are evaluating phrases that use the symbol and, you want to say to yourself, and is only true when both are true. So in other words, any statement that uses the word and, you've got to do both parts. So and is only true when both are true. For the symbol or, we say that or is only false when both are false. So when you're looking at two statements joined by the word or means you only have to satisfy one of the statements or both, and the only way it's going to be false is if you don't satisfy either. So or is only false when both are false. Now, with our conditional, remember that is your if-then statement. Our conditional is only false when you have a true followed by a false. So it is only false when you have a true followed by a false. An example of this would be, let's say that I won the lottery. That's my true statement. And then I go to collect my winnings and they don't pay me. That would be my false statement. So in that case, I won, but then they didn't pay me. So that's when it is false. It is only when you have a true then false. Now, with my biconditional statement, remember that is your if and only if. That is going to be true when both statements are the same. So if you have a true double arrow true, or you have a false double arrow false, you'll get a true statement. Otherwise, you'll have false. And then finally, the negation means that you take the opposite truth value of what you have. Now, let's apply these to an actual truth table. So when I'm looking at this example down here, I'm going to overall evaluate the Q or P, and then the biconditional with Q. So in this box, we're going to start with the parentheses first, evaluating Q or P. So remember, or is only false when both are false. So as I'm going through this table, I'm looking at these two statements. And so what I'm saying to myself every time I look is or is only true when both are, or is only false when both are false. So if I don't see both false, as I go down the table, I'm putting trues. But the minute that I see both are false, I'm going to put a false within that table. So you learn these sayings and you say that to yourself as you are building the tables. Now, I'm going to compare those values that I got to my Q values. And I actually like to put them so that I can actually see them. Since it's the double arrow, you can actually be looking right next to it, or you could rewrite them. But basically, here are your Q values, and then there are your Q or P values. And we know with the biconditional that it is true when both statements are the same. So I'm looking to see, as I go down, I'm looking to see, are both statements here the same? Yes, they are, then it's true. Are both statements the same? No, they're not, so then it's false. Are both statements the same? Yes, it is, so then it's true. Are both statements the same? Yes, it is, so then it's true. So these are my final answers in terms of that truth table. All right, when I look at the next one, and here they're telling me certain starting values, so I'm just going to kind of fill those in. So they're telling me P is true, so that would be a true here. Q is false. So that would be a false. And notice there's a single arrow between those two. So if I evaluate that, that is a conditional. I know that with the conditional, it is false when I have true then false. So overall, that is a false right there. And then I'm going to bring down my and symbol here. And then, so once again, they told me that my p-value was true. So that's a true here. And then I have an arrow again. And they're telling me my r value is true, but notice this says the negation of r. So if r is true, the negation of r is false. And so once again, if I evaluate that set of parentheses, I know the condition is false when I have true then false. So that would be a false as well. Those are inside brackets. So now if I evaluate the brackets next, when I have a and statement, it's only true if both are true. So in this case, they're not both true. That would be a false. And then when I negate the false, overall, I get a true. So you're just plugging in and evaluating just those that particular statement. Okay, so down at the bottom, I'm going to see if my two statements are equivalent. Now, what I like to do is I like to, especially if they're going to do something like a negation, I like to write those values first. So if I'm looking at my column P and I negate those, if P is true, the negation is false. If P is true, the negation is false. If P is false, the negation is true. And if P is false, the negation is true. I like to put them there. And especially when I'm dealing with this conditional, I like to put my Q statements over here because the order does matter. Remember, when you are evaluating the single arrow, what we call the conditional, it is only false when you have a true then false. So this would be true overall, this would be true overall, this would be true overall. And here, because we have a true then false, that would be false overall. So these are your final answers in this particular truth table here. And then if I build a separate truth table for the second statement, this time I'm going to be looking at not Q, arrow, not P. So if I come back over to my Q values here and I negate them, I will have a false, true, false, true. And then when I'm looking at my negation of my P values, I will have a false, false, true, true. So then finally, I am looking at the single arrow condition, and I say to myself, the conditional is only false when I have true then false. So in this first row, it's true. This would be false because I have true then false. This is true and this is true. So when I compare my final answers to this statement with my final answers to that, notice they are different. Row 2 here is different and the bottom row is different. Well, if there's any difference, they are not equivalent. They have to be exactly the same in order to be equivalent. So these are not equivalent.